Hello everyone. Now we have a question based on the CFSE. So we have to apply the crystal field theory for this question. And it says for octahedral geometry, the triad with no net gain in CFSE when the ligand field changes from weak to strong is. Okay. Triad means we have to identify from each of these three sets of complex ions, metal ions that have been given as options. So what is the meaning of this question? This question means that we have to identify that set of metal ions where the CFSE does not change even as the ligand character changes from weak to strong. Okay, so as the ligand character changes from weak to strong, there should be no change in CFSE. So that is the question which is asked. That means the electrons that are occupied in the T2G and EG orbitals that need to be same, that need to be arranged in a similar manner irrespective of the strength of the ligand. Now we will see how that happens and what should be our answer. Okay, so now let's check the first triad which consists of Fe2 plus, CO3 plus and Mn3 plus. Okay, starting with Fe2 plus. Fe2 plus means we have a D6 configuration. Now in the weak field, so first we check for the weak field. Okay, weak field ligands. Then in the weak field ligands, it will be arranged singly first. The electrons will be arranged singly first as high spin. Okay, so singly occupied 1, 2, 3, 4, 5 and then pairing here in the T2G. That is the weak field. Now if that same thing has to happen in the strong field. So strong field, we know that pairing has to happen. So electrons get paired. So the D6 electrons, they all get paired and then they get accommodated in the T2G orbital itself. So you can see here, the situation here is different from the situation here. In the high spin, we have 2 electrons in the EG and 4 electrons in T2G. While in the low spin, we have no electrons in EG and 6 electrons in T2G. That means the CFSE will definitely change in these two situations. Now this is how we have to identify each of the cases of the complex ions. Now CO3 plus. So CO3 plus again has a D6 configuration. We know that cobalt has 3D7 4S2 in the ground state and in the plus 3 oxidized state we have 3D6. Okay, again D6 configuration. So this D6 will be similar filling of D6 electrons as we saw for Fe2 plus. So that means in this case also the CFSE should change. So CFSE changes for CO3 plus as well, Fe2 plus CO3 plus. Okay, then coming to Mn3 plus. Now for Mn3 plus, okay, so we have manganese 3D5 4S2 in the ground state and then in the plus 3 oxidation state it will be 3D4, okay, 3D4. So D4 configuration. So D4 configuration in the weak field high spin complex will be singly occupied first. So 3 electrons in T2G and 1 electron in EG. Now similarly, under the strong field influence, so strong field ligands forming the low spin complexes. So pairing will be favored. So 1, 2, 3, D4, 3D4. And the fourth electron goes to the T2G orbital itself and gets paired. So this is T2G4. Here T2G3, EG1 and here we have T2G4. So in both the cases, the electronic arrangement is different in the T2G and EG orbitals. So for Mn3 plus also the CFSE changes for weak and strong field ligands. So this first triad is done. So this is not the correct triad. Now moving to the second, nickel plus 2, Pt plus 2 and Cr plus 3. Now for nickel 2 plus, we know that nickel is 3d8, 4s2 in the ground state. So Ni2 plus will be 3d8. So we have a D8 configuration. Now D8 configuration under the weak field ligands, high spin complexes. So singly occupied first, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have T2G6, Eg2. Now in the strong field, what happens? First the pairing 1, 2, 3, 4, 5, 6, then 7 and 8. Okay, now if you observe carefully, we have the same configuration. So T2G6, Eg2. And here also we have T2G6, 6 electrons and Eg has 2 electrons, Eg2. So same configuration, same pattern of filling of the D8 electrons in both the T2G and Eg orbitals, which gives rise to a situation where the CFSE, if we try to calculate it, does not change. So for D8 configuration, the CFSE does not change irrespective of the strength of the ligand, strong field or weak field. Now for platinum 2 plus, we know that platinum is in the third transition series and the expected valence electronic configuration will be 5d8 6s2, but actually it is 5d9 6s1 for stability. So now we have to arrange these 9 electrons. So it's a d9 configuration, 5d9. And first of all, similarly we arrange these in the high spin or weak field conditions. So high spin weak field means first it will be singly occupied, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that means we have T2G6 and Eg3, okay, in the high spin or weak field condition. Now in the strong field or low spin condition, okay. Now in the strong field, low spin condition, so first the pairing should take place 1, 2, 3, 4, 5, 6, 7, 8 and 9. So again we have the same electrons in T2G. So T2G6 and Eg3. So this also does not change. So we have for platinum 2 plus in the weak field conditions, we have T2G6, Eg3, and in the strong field conditions also we have T2G6, Eg3. So in both these cases, the number of electrons remain the same in both T2G and Eg orbitals. So here also the CFSE does not change. So for platinum 2 plus also there is no change in CFSE. Okay, so one situation we got, nickel 2 plus and platinum 2 plus. Now let's check the Cr3 plus. Okay, chromium in the ground state is 3d5 4s1. Now if chromium is in the plus 3 oxidation state, then it will be 3d3 4s0. So we have 3 electrons in the d orbitals. That is the D3 configuration. For D3 configuration, we can accommodate only 3 electrons in the T2G orbitals. So for D3, it is always T2G3, whether it is high spin or weak field, or it is low spin or strong field. So in both the situations, there is only one option that we fill the 3 electrons in the T2G orbitals singly occupied. So T2G3, both in the strong field as well as in the weak field. Okay, so here also, since there is only one way of filling these 3d electrons in the T2G orbitals, Here also the CFSE remains the same for the weak field as well as strong field ligands. So CFSE does not change for chromium 3 ion as well. So for this triad, nickel 2 plus, platinum 2 plus and Cr 3 plus, the CFSE does not change. Okay, so this triad will be our correct answer for this question, where we have nickel 2 plus, platinum 2 plus and chromium 3 plus, where the CFSE does not change irrespective of the strength of the ligand. So I will be concluding here for this question, but I would request you all, please, you should try these third and fourth options as well, where we have Mn2 plus, Fe3 plus, nickel 3 plus, different oxidation state of the metal ions, then cobalt 2 plus, osmium 3 plus, rhodium 3 plus. So all of these ions, you should try to write the valence electronic configuration and then accommodate the d electrons in the T2G and Eg orbitals and check the influence of the weak field and strong field ligands, and then check whether the CFSE changes or not for any of these. I have told you the system, I have told you the steps, I have explained that how you can check the change in CFSE from weak to strong ligands, and all you have to do is to apply whatever you have learned from this explanation to these ions. Please do it, because it will be very good for your own practice. And I hope this explanation is clear to you. So the correct answer will be our option 2. And hope it is helpful, and thank you so much.